All right, in this video, we'll discuss superposition. And superposition is a property of linear systems. This method can only be applied to circuits, say, that have a lot of voltage sources, resistors, and current sources. You can't apply superposition to a circuit that has nonlinear elements. And examples of nonlinear circuit elements are things like diodes or solar cells, or any circuit element really that has an IV plot that's not a straight line. And here's what superposition says. If you have a complicated situation with many different sources, you can isolate the influence of one source on the output. Let me show you an example circuit. We'll just work through the example and you'll see what superposition can do. Let's assume that we have a 3-volt source, a 2 ohm resistor, another resistor of 2 ohms, and I have a current I, and I want to know what that current is flowing through that resistor. Well, superposition is only useful if you have 2 different sources. You see, right now it would be very simple to calculate the current, right? Because I have 3 volts, 4 ohms in the path, so V equals IR, so I would be 3 divided by 4. But what if I had another source? And let's say I put the source up here, and I have it turned around funny like this, and I have another resistor. And then I could calculate the current. Well, I wouldn't necessarily have to use superposition to solve for the current. I could, of course, use the Kirchhoff voltage law, the Kirchhoff current law, or node voltage analysis, and that would definitely give me enough mathematical, knowledge in order to solve the circuit. But superposition allows me to do something else. If I glance at the circuit and I see only linear circuit elements, and that's the case here, right? I have resistor, voltage source, resistor, resistor, voltage source. They're all linear. I can use superposition. What superposition allows me to do is to say what the current I is due to the 3-volt source, and to say how much of the current I is due to the 6-volt source. In other words, I can isolate the influences of each of these voltage sources independently, and then they add up to give me an answer. The easiest way to do this is to illustrate through an example. And what we'll do in order to isolate the effect of the 3-volt source is to zero out the 6-volt source. So let's just write the equation temporarily here. So current, I can divide it into 2 allocations. This current, I, passing through the 2 ohm resistor, is the sum of 2 currents. One current is due to the influence of the 3-volt source, if you will, and part of the current is due to the influence of the 6-volt source. And superposition allows me to isolate these 2 influences. In order to do that, I have to zero a source. So how do you zero a source? Well, imagine that you have a voltage source and I say zero out the source. Well, you could imagine sitting in front of a DC power supply with a knob. You just turn the knob down to 0. In other words, if you've got a 6-volt source, turn it down to 0. A 0-volt source behaves like a short circuit. Imagine that you have a current source and I say zero out the current source. What happens? Well, if a current source is set to 10 amperes and it has 10 amperes flowing through it, and I zero it down, turn the knob down, and I get to 0 amperes, then no current flows. It's like an open circuit. All right, so let's find this current due to the 3-volt source. Let me redraw the circuit here just a little bit, because we have a 2 ohm resistor, and then you could see that these 2 resistors are actually in parallel with one another. So I could imagine that they're aligned like this instead, and the circuit doesn't really change. And each of these is 2 ohms. 2 ohms in parallel with 2 ohms is just 1 ohm. So we have in total of 3 ohms across this part of the circuit. 3 volts over 3 ohms is 1 ampere. So we have 1 ampere of current flowing along this path, 1 ampere of current flowing through this resistor. And because these 2 resistors are both 2 ohms, I'm going to have a ½ ampere flowing through each of them. So I3V then is going to be a ½ ampere, which means that in my original circuit, we're going to have some current flowing through the 2 ohms. And whatever that current is, I will be able to say that ½ ampere of that current is allocable to the 3-volt source. Now let's find how much of the current that will ultimately be flowing through the 2 ohm resistor is due to the 6 volt source. So to do that, we need to zero out the 3 volt source. Let's find the current allocable to the 6 volt source. All right, so the current is going to flow out of the 6 volt source, and we can redraw our circuit just a little bit by let's move the 6 volts over to the left and kind of reposition it a little bit. So the 6 volts here, I start here. We've got 2 ohms coming up, and then I have a split at this node to 2 ohms, another 2 ohms. So we have a split in both directions, and then they recombine, and then I wind up at the 6 volt source. So we have something like this. Current is labeled coming out with my red label. Maybe I could call this I2 just to keep things straight. And then my I6V, which I've got labeled as going down on this diagram, would be labeled from right to left. All right, so the total resistance we have in the path would be 2 plus 1, or 3 ohms. All right, so let me go ahead and draw that. 6 is I2 times 3. I2 is 2 amperes. How about my I6V? This current is going to be equal to that one because the 2 resistors are the same, so the current has to divide evenly. So I could say that I6V is negative 1/2 of my I2 because the arrows are pointed in opposite directions. Since I2 is 2 amperes, this is minus 1 ampere. So I6V is minus 1 ampere. And I can now look back and see, due to I3V was a 1/2 ampere and minus 1 ampere, so I can fill in my equations. 0.5 minus 1 minus 0.5 ampere. So that's the total current flowing through the middle resistor, and it shows what superposition can do. Superposition allows me to allocate what portion of the current is due to sources, and it only works with linear circuit elements. If one of these resistors, for example, had been a diode, or one of the sources had been a solar cell or a battery that's not perfect, then this method would not work. But what's very special about this method is that if you have a complicated circuit with many sources and you want to know, well, what effect does this one particular source have on my output? Well, then this method allows you to find that out. And it's a very interesting method for that reason. So in this circuit, I can say, all right, I have some current flowing through the 2 ohm resistor. Part of that current is due to the 3 volt source, part of that current is due to the 6 volt source. And anyway, it's an alternative method for solving the problem. If you enjoyed watching this video, then you might be interested in following our playlist and learning more about the fundamentals of electrical circuits.